In today's lesson, we'll talk about inverses and matrix equations. Before that, we need to discuss an identity matrix. An identity matrix is a n by n matrix for which each main diagonal entry is 1 and for which all other entries are 0. So when they say main diagonal, that means starting from the top left and working all the way down to the bottom right. So all those entries are 1, and then everything else is a 0. And being an n by n matrix means you have the same number of rows as you do columns. For identities, you would be able to multiply any matrix by an identity to get that matrix back. An inverse is when you take a matrix times the inverse, and that gets you the identity. And so we use that to help us solve matrix equations. Okay? Those also are going to be square or n by n matrices. In the first example here, we want to verify if these two matrices are inverses of one another. So in doing so, we need to actually multiply them and in both directions. So because matrices that are inverses of one another are actually commutative because they both should get us the identity matrix. So in this case, I'm going to multiply A times B and then B times A. This one allows me to do so because they're both 2 by 2s, so they have the correct dimensions to be able to multiply. And so in multiplying the first one of A times B, I actually do get the identity matrix of 1, 0, 0, 1. Then doing it the other way, give me the following matrix. B times A also results in the identity matrix, so therefore these are inverses of each other. Now we can also find an inverse given a matrix by using this formula of 1 over A times D minus B times C multiplied to the matrix of D negative B negative C A. So what we're actually doing is we're finding a scalar that helps find the matrix or the inverse of this matrix, and then the values on that main diagonal switch. So in this case 4 and 3 will switch, and then B and C, so in the other diagonal, they become the opposite sign. So if they're negative, they're positive. If they're positive, they're negative. So doing so will allow me to find a inverse of this matrix, which is 4, 5, 2, 3. So it looks like my scalar is 1/2, and the other part of the matrix is 3, negative 5, negative 2, 4, and then I multiply that 1/2 through to get one 2 by 2 matrix, which will be 3 halves, negative 5 halves, negative 1, negative 2, or sorry, positive 2, and that's my inverse. Okay, we use inverses to help us solve matrix equations. So first I want to put this into a matrix equation format that we did in the last video, where I take out my coefficients and put them in a coefficient matrix, then make a variable matrix for x and y, and then make a solution matrix for 15 and 36. And then from there, it's kind of like solving. So instead of like dividing or doing something else here, we actually multiply both sides by the inverse matrix to undo the matrix that's being multiplied to the x and the y, so the variable matrix. And that gives me the identity matrix, which also disappears because it's like 1 times x makes it just x. So here I'm just finding the inverse for this 2, negative 5, 3, negative 6. It looks like it is an inverse. One thing I didn't mention in the last part was that if you don't have an inverse, then you can't solve, so there's no solution there. The only way that happens is if your A times D minus B times C becomes 0 or is 0. So in this case we get 3, so there is an inverse, so we can actually solve here. So then now that I have this, I'm going to multiply both sides by my inverse. of -2 5/3, -1 2/3. So now I multiply my inverse to my original coefficient matrix. And I'll do the same on the other side to my solution matrix. So now I can see that on the left I got the identity matrix, and on the right I get 39, 30, and then 9 at the bottom. So then my solution is actually 30, 9. And then here I'll do the same thing for this equation. So set up my matrix equation, and then I want to be able to find my inverse. So now I got the number that's not 0, so I know that I have an inverse. So I can multiply that -1/16 through the matrix. And then I'm going to apply that to my matrix equation by multiplying that to both sides.
Are you
So now I'm able to get the identity matrix on the left, and then I get my solutions on the right, which will be 1 for x and 10 for y. Hopefully you found this video to be helpful. Thanks for watching.